So, let's get started. It's pretty late already. So, let's get started. We've got a bottle full of tea to keep us through the night, or how much I can, and we are going to something. I don't know exactly. This is a great start because words are hard. I'm actually currently using this new Emacs branch called GCC Emacs, which uses native code compilation on the packages. We'll see if we see a difference. I've been using it for a couple of days, but I haven't done any programming heavy things, nothing that really stressed Emacs all that much. We'll see how this works on a file that's still almost 2,000 lines long. I wanted to talk about something. Yes, about systemf sort of things. So I mentioned last time that I could probably abstract over modules type things as long as I don't assume excluded middle, and actually it will prove the negation of excluded middle. However, there was a point that I didn't think about. This lets us do a systemf with products and lambdas, and probably there's no problem adding sums and so on and so forth. However, I'm pretty sure U doesn't usually contain the type of proposition, and probably no type of proposition. Why is that? Because if U captures set, I'm gonna remove the indicator. Yeah, set of propositions. Then we have just built a variant of system U minus. Which is known to be inconsistent by Hurwitz's paradox. What is U minus? It's basically you have two different kind of types, sometimes called types and propositions, or big types and small types, but let's call them types and proposition. What you need is for types to contain systemf, I think, and for propositions to be able to quantify over types and make a proposition. And if you have this, then you have a paradox. You can prove all propositions. Let me quickly grab a link. Right, because I went and looked at it recently. So a few years ago, roughly 5 years ago, I wrote this. So that's very, very small, I assume. Can you see it? Let me check something. I had a ton of technical problems, so I want to check. No, of course you don't. Let me... What? Fascinating. This is terrible. Okay, let me do that okay. Sorry. Stop this. I'm gonna have to do this manually. It's gonna be awful. I'm gonna use the browser as little as possible. My usual scene switcher just stopped working today, and I don't know why. It's not even detected by OBS. It's like it isn't there. I'll have to figure this out. But it's something I'll try to do another day. Right. So, Ergen's paradox uses a theory like this. So this is something I wrote in the Cog Proof Assistant. One recognizes my style because there are a lot of Unicode, I guess. But joke aside, you still need something that looks rather like a dependent product or something like this. So maybe what's the theory for? So anyway, we have this thing like yeah, right. We have a type U1 here. That's the large universe, the types, and there's a type U0, which is a small universe, and you have this. There's a version of U0 that decodes to blah blah blah. To a type that. And some of the details don't matter all that much. I also wrote a small note. You can find it on my website on this. It's like a 12-ish page explanation of what's going on, as I understood it at the time, which was not a lot, and I don't think I understand it better now. So I'm not exactly sure what we need, but making a system F over a set of proposition is flirting quite a bit with inconsistency, because we do have the big for all here. I'm not sure we have this one. Right, these were notations, so some of these are redundant. The point is, so we have a type U1 together with a way to quantify over everything in U1. Like every type can be the domain of a for all. The round, can do full. For all x colon u for any u in U1. So that's just regular for all. And that's probably needed. I'm not sure. And we don't have that, so yet. So we're kind of planning on it. So we're playing very, very close. There's a few equalities as well, I think, that we need. Again, that we might not actually have. Where were they? Beta 1 is my beta U1. So there's two beta rules here and here. Anyway, I haven't studied that very closely. But my point is that I don't know if it is completely inconsistent, since it seems to be missing a hypothesis. Oh, there was a completion, or two from say the Hurricanes.v. However, it may... Ooh, that's maybe wiser to restrict to... or like restrict or to make module quantified things be somehow bigger. Either by restricting to prenex quantifications or some other mechanism. At any rate, we are flirting with inconsistency. Inconsistency. Funny. So there you have it. Cannot load fly spell correct Helm. Didn't I just do that? I just did. That's just weird. Like, this is a branch of master. It is very, very fresh, and there are weird behaviors in my Emacs nowadays. But it's faster, maybe. So back on our so this is not finished. I want to do the less light syntax thing. So what do I want that? So why Lisp? Well, this avoids that, like, tactics introduce a lot of syntax, like a real lot. Each tactic kind of wants its own syntax, and parsers don't like this too much. And I don't like spending time in parsers. Lisp has a very irregular syntax. With the property, well, not really the property, but the like the trait of like handling optional arguments really well. Like, for instance, you could say, oh, so okay, you could use some tag and mandatory argument here, or mandatory. Let's put a space to say there are several, and then colon keyword and some optional arguments, something like this. Plus, we are actually doing a lot of list of tactics things. Either sequences or dispatches. Having an n-ary syntax is pretty good. Sarah. LSP, like something in the LSP, what's the word? Stack is really mishandling a file of this size. I said last time that it was a good incentive to do some refactoring, but I haven't been in any mood to do that offline. And if that's not enough, if that's not, furthermore, if that's not enough, Lisp traditionally has a stellar story for macros, which tactics tend to need. I'm not going to implement racket style macros anytime soon, but the possibility is reassuring. So that would be my motivation. Sorry, I'm dealing with some distracting stuff. So that's sort of the idea. I should yeah, well, I'll make the commit disappear eventually. So what I think we're going to do exactly that. So the plan, what would it look like? So in the neighboring file called refine.hs, there is a syntax, and I think my LSP just died. Okay. We'll turn off LSP here. I can. No. Ooh. This is a problem. What's happening? Interesting. Right. Icon off. And maybe remove LSP mode. Yeah, maybe that worked. Does that work? No, it didn't work. Okay, that's going to be a bit difficult. Maybe it's an incentive not to spend too much time in this. Okay, so what's happening here, I think, is this slice is generating a tone of warning that I have deactivated one way or another. I don't remember how. And this is thoroughly confusing my LSP. And it may crash my Emacs, may already have crashed my Emacs, which is an interesting situation. Ooh. I don't know if you're seeing what I'm seeing. It's I don't think you are. There's a gigantic. No, you're not seeing it. Emacs is extremely confused and gives me like hundreds of warnings. Okay, LSP. My workspace shut down. Can I do this? This, yes. We'll restart it in a minute. That's not sufficient. Maybe if I do revert buffer. It's just started the thing again, probably. Yeah. I would have trouble for 5 seconds. This is going to be a problem. What can I do? I can remove Haskell's mode here. Can I just go in vanilla prog mode? Here we go. Oh, that's all way out. So this is vanilla prog mode in Emacs. Okay, so let's just do a little Emacs parenthesis digression thing. So Emacs is organized around modes, and most of the behavior that we teach Emacs to have are are restricted to a mode. So I can show you something. So the way I activate LSP is by saying, that's a bit weird, but like it says, oh, if this is Haskell mode, then after evaluating this dir locals, that's the directory local variable file, then please do run LSP. It's not exactly the same as adding LSP to Haskell mode, but the point is this only happens in Haskell mode. But the interesting thing about these modes is that they sort of inherit from something else. So there's a inheritance relation, and the basic mode where everything starts that is given from scratch by Emacs is fundamental mode. And if you change something in the fundamental mode, it's a weird word to say, is it? It's a French word too, so I don't know why I'm struggling with it. So in fundamental mode, if you change anything, everything will be changed, every single buffer you have. And then this sort of splits in two. There's the text mode that is used by like text editing, markdown, org mode, whatnot. These are text in the text mode family. It's just a branching tree. And prog mode is the mode from which all programming language inherit, and it defines things like what is a comment and things like this. And this is why you have comments like that's meta semicolon that adds comments around something, comments something out, and this is sort of all the same because these are things defined in prog mode, and the prog mode derivatives, these like Haskell mode and so on and so forth, will simply fill in the gap, saying, "Oh, this is what a comment looks like," and things like this. What I did here is I said, "Oh, but because LSP is only run within a Haskell mode file, and this is really not much of a Haskell file, so let's just give up on the Haskell goodness and go." There's these things that are still here, which is very interesting, but it's not running LSP anymore. I don't know what happens when I click them, but I don't really want to try. So the point is, or entry for tactics. I don't know if you can see that here. So let's go back to main. Our tactic lists of this form. So you do a theorem, and then it's asking for a list of tactics, which is a sequence, which is not a sequence, but one per goal. So here there's a single goal, etc. What we're going to do is we're going to add a new syntax for a list of tactics. And we're going to write that syntax, and we're going to have the two syntax in parallel. But then we have a sort of like tag apply or something. Apply tags. It takes it takes actual tactics. So no, that's not the one. And check programs. We're calling your mtag calls mtag type check proposition. This tax thing is not interpreted yet. I think maybe it is actually. Concrete, yeah, it's concrete syntax. So no, it's not interpreted. Lispy is not running now. Interesting. Okay. So apply mtags. That's the one. Maybe tag out. Apply tags. Eval tag, that's what I was looking for. It was just right behind my nose. So we have this huge dispatch, and we'll have to replace by another kind of dispatch, but that uses list syntax instead. So in a way, the syntax will be defined. So we'll have a second eval tag that will just do this sort of thing, and then we'll only add things to eval tag. But then we'll have a single function where we define the syntax instead of two. So that's sort of the story. Okay. So let's have a look at theorem. We term a maybe tag out. And maybe tag out is defined somewhere. It's here, it's either tag out or nothing. And so that will be this, or how do we say or again? Oh yeah, we just give a different name. So that's tag.lisp. That gives me a tag out, and I will just take a this tag thing. And we need so this is not quite generic Lisp because we would need a way to pass a term, something of type expression. Let's define this. Yes, so and there will be some weird things, like we have to figure out, like I think we're going to use like symbols to represent variables. I don't know if they're going to be bound or if I will quote them. I probably will quote them actually. If I quote them, I can't check that they're whatever. I'll see. So list tag. So we need it can be a symbol. A symbol. We'll say that it's an identifier for now, but that's not quite right. It can be much more general than this. It can be a keyword. How do I define that? I'll probably change parsing engine eventually. I need to figure out. So how is ident defined? Because I really want to do ident, but just with a colon in front of it. So how do I do this? I think we have to go back to. Oh, I need to do them. Code browser. I'm gonna forget once, and I'm gonna be programming with the browser open Please tell me. So what I wanted to do, oh yeah. What's the name of this package again? It's LBNF. That's great. BNFC maybe is what I'm looking for. BNFC meter, but really I need BNFC's doc. Algebra.ring utils? No, that's... What? What? I'm confused about this document, but I need this thing. It's all right. There's this thing. We can look at the documentation. Here's the manual. How big is it? I'm gonna put it a bit bigger. Okay. And I'm gonna look for items. So we can we use this syntax in so there's the Lexer definition. We'll have to say token. Okay, so I don't have to define a new type. It's going to be given to me. So, okay, I need to switch. Oh dear, this is going to be a very laborious session. I'm so sorry. I lost my my list thingy. Oh, keyword gives me a list tag, and we'll take a keyword, or a list keyword, let's call it, because otherwise it's going to be confusing. We have to define this as token. What is human here? Oh, that's upper letter thing. Okay, it's so I want to say keyword. So it's really funny. It looks like there's a space, but there isn't. It's just I think it's just a rendering of the. Oh, you don't see it anyway, so whatever. The token keyword. So that's upper bound thing, but I don't really care about this. What I want is, let's say it's colon, followed by a letter, followed by a letter, this, or this, as many times as I want, and probably other things, but I don't care right now. Okay. That's taking a long time to reload. But this is good. Okay. And finally, there are several things that match on tac help. That's tac out, sorry. That's interesting. And finally, we have a list. list is list tag colon equal. I think I'm going to change something there. So it takes a parenthesis, then list tags, another parenthesis, and there we go. I need to add a separator thing. List tag. Nothing, I think. Right. That's probably not enough. Or is it? It is. Wow. Hey James. Why are we implementing a list now? How are you doing? You haven't missed that much because summary of the past few episodes. I did a super compiler that is currently buggy but was extremely fun. We can find it here. No, not here. Sorry. We can find it here. Compile. So, you saw part of this actually. I remember. You saw most of this. Then I got ill. I haven't fixed it, by the way. Oh, and I did a bit of refactoring last week, well, 2 weeks ago. And that's because I implemented. That's something I implemented offline. That's a terrible way to navigate. Whatever. I implemented a small binding library. A small generic library for De Bruyne binding that gives me all the syntax things. I'm going to change things soon on this, but the general idea. Right. Okay. Thanks. It's basically a multiplate type library that applies to De Bruyne. It is not safe or anything, but it gives you a few tools. The main tool would be this lets you mark a binder by how many level deep it will get you, and it gives you traversals for immediate subterms, and it's very easy to define substitution. I also have this, which I haven't tested yet, which is a type of substitution that supports composition that is completely generic in the type that you're using it for. As long, well, the way I use it, the type class here, that is the helper to define it, supposes that there's only one kind of variable, or at least that there's one kind of variable by type of substitution. So, no, it's not that one, it's substitutable, which is, I don't know where it is. Here it is. Okay, so that's the one. And it's really, really simple. It's a very small library, but we used it to refactor the main code a bit, and I'm going to use it on the super compiler at some point to try and reduce the amount of code that I have to debug. Anyway, why are we doing Lisp? Well, a few months ago, someone mentioned that Lisp was a good way to write tactics, I guess. That's not exactly how they put it, but that was the general idea. And I wrote a bit of syntax for the tactics, and it started getting annoying. And I was thinking, yeah, actually, tactics are really a perfect use case for Lisp, because they tend to be lists of things, either sequences or dispatches. So these are very n-ary things that Lisp understands, fairly easily, and they also, it's very easy to code optional arguments, and that will, or reorder arguments and things like this by using keywords. So the consequence of this is that it will probably make everything way simpler, and sort of at a horizon that we will never reach. Lisp also has a good story with macros, which is a very, very useful thing as far as tactics are concerned. So yeah, I think like instead of trying to bother with a super complex syntax for tactics and one syntax entry every time I add a tactic, it's probably just as well using a Lisp beyond the implementation horizon, pretty much. So yeah, that's what you missed. That's not that much. I think. Right. It's the tactic language that is running a Lisp. That's the idea. I'm not in the right file. So the idea here is we're going to progressively remove this alternative in favor of this one, but we only use Lisps for tactics, or Lisp syntax for tactics. So that is good, but I'm going to change this. I think I'm going to force it to be a Lisp because I know it's going to be. Maybe later I can make it a normal thing and it can take a single tactic, but right now we're going to assume it's a list of tactics. Okay. So we don't have the entire syntax. I need another case. I need a case that says this is a term, because I think I have some terms. Do I? No, actually. Oh yeah, I do. Like half term, focus term, and these terms I need to pass them as terms, as there's not really a way around it. Well, I'm not using a parser generator to parse S expressions. There's two reasons for using a parser generator. It's the code that surrounds the S expression, and also the code inside, which is like embedded term. I don't know. I'm going to call it tac term. It's terrible. This is weird. What does this even type? List tac. And I don't know, I'm going to use brackets, like square brackets. That is tac expert, really. No, not tax expert. What is it? Is it term? It's term. Okay. And brackets are honestly very good a choice. So this is the one reason to, like the main reason to use a parser for the S expressions. So we can't really rely on a generic S expression reader thing there. Then I'll have to, I'll fix this. Actually, I can fix this right now, I guess. But yeah, let's do this while I still know how to do it. That's a fairly easy way to solve this. And I will probably need quote as well. Ah, I broke something. That's hilarious. Why? For shift reduce conflicts. Why? There's no, sorry. If I remove the Lisp ident. Ah, no. It was before. When did I introduce it? I never understand parsers. What is ambiguous and what isn't. Oh, I remember there was this. This had no name. This is a bug in it, and that was okay. No, it wasn't. Is this a problem? I think it's this one is the problem. No, it isn't. I don't know. Okay, so let's try and figure this out. Why could this be? Why could this be a conflict? Passes F. I'm just saying it's a term. Then you see a parenthesis. There are 4 shift reduce conflicts. And what and what? This is because there's a parenthesis term here. If that's the case, I could just remove the conflict by doing this, right? But I don't. There's just as many. Is that because of this one? Nope. I don't see why that would be anyway. What's happening? I hate parsers. I mean, I don't hate them that much, but they kind of hate me. I never understand what I do wrong in these. Can I remove this and get something that works? Actually, that's weird because there should be warnings. I think it's not reloading properly. Like if I remove all of this and go back to my normal thing, it will still bug maybe. Give me an error. Right, not anymore. Okay, now I can try new things. And that introduces the error. Fascinating. Only 2 anymore. Do I have square brackets somewhere else to start with? Right, that's a good point. I use square brackets in tactics. And parentheses everywhere. That shouldn't be a problem. Now this is a bore. I'm gonna figure this out one way. Oh, and I've been using the new LSP thing for Haskell. It's kind of working, though it breaks on this file like terribly. Oh, these. That shouldn't be a problem. Parentheses should be well balanced, so there shouldn't be a problem parsing this. These are the explicit parentheses. B paren. Binder. Let's have a look at which term f of f(1) is. I assume it's the first one in the file, but I'm not sure about that. Yes, it did that to me last time because it. There's been a couple of examples, but the most egregious was that it forgot to add parentheses where it replaced a symbol by like several in an expression that was composite. Right, that is the first thing. What happens if I comment this out? Then I get a syntax error. The next thing, that doesn't even have a parenthesis or a bracket. And that's an error type, so ouch. So I guess the syntax is completely wrong right now. And I don't know why. Just checking that there's no other things called list tag. This all looks very reasonable, and I don't know why there would be any sort of doubt, because these two things are perfectly. Oh, why in R type too? This is before and next column. What is this? It might be the existence of the list item thing, because maybe it tokenizes wrong now. Right. Okay. So I think we'll need another parser technology if we want to fix the idents. So I think what's happening is, well, tokenization is not context aware, and because my ident type is a supertype of the normal ident, it would parse everything as Lisp idents and never find idents and say, oh, there's an error. I think there's still 4 shift reduce conflicts. I have no idea why. We can still have issues if we do colon and not add a space, which is fantastic. I love parsing. For shift reduce conflicts. For shift reduce conflicts. I think for a few minutes in my life, I've known what a shift reduce conflict actually was. Probably several spans of few minutes across years, but I never remember what that means. And I don't know how to fix this right now. Let's move on a bit. So I mean, file tag. Oh, that's funny. I'm seeing one conflict now. Calls tack out. Okay, let's. I wanted to no. Okay, I lost my my point. Maybe tack out. Let's use the exactly ones instead of putting. This. I'm going to call that lisp tack out, and I'm going to call that the same. And I'm going to here in maybe tack out. That's going to simplify a bit. There's only two on multiple, just tack out. Oh yeah. Just lisp tack out. Naturally, there are fewer shift reduce conflicts already. Maybe. There are two. Isn't that much better? I don't know why there are two. I guess there's somewhere in my tack out thing. This looks very, very deterministic. I wish it would give me more data. I guess if I use the actual BNFC tool, I'll get more data, but I don't have it handy. So we'll see data. But now we have a single missing pattern, so that's good. The LSP can't see it, of course it can't. 1362. Right, so we need another one here. And for that, we have our lisp tack concrete dot how did I call it? Lisp tack? Lisp tack to tack. It is completely bogus right now. It says not in scope, so I have to word buffer maybe. No, maybe workspace. I think it's just a bit confused. Okay, now it's good. We'll play with examples later, but first we have to fix this. Just lisp tack out concrete lisp tack out eval lisp tack. Let's see how this goes. Okay. So right, there's a code for this, but I don't know what it is. Lambda case split, I guess. didn't know to put the interesting bug that. I'm not sure that's quite what I want to do. What should a tactic look like? I guess it should be parenthesis something something. So really, my only interested case here, when I want a tactic, is a list. The rest should be I also already see the problem that I'm not giving any location indication about what's wrong, but it's not worse than currently. I actually don't know how to do that well. Actually, so this is going to be a list. So I want it to be of the form symbol, rest, where this actually being a symbol. Symbol. Okay. Really want to write patterns. So for the simple ones, would be something like, oh, this is sim and nothing, so just this is, oops, it's going to complain because sim is not a string. Right, so I'm just going to write concrete.ident, but I should just use overloaded strings here, I think. Ooh. This is my first time doing this. Oops. Okay, yes, there's a hole here. Shoot. Kill this. Yes. Where were we? Okay. Oof. That's easier to write then. Of course. Apparently LSP mode right now is pretty bad at qualifying things. At least this tactical programming thing. Okay. So we can do the same thing for T-don, for don, so which is discharge. Induction is more interesting. Should we be writing induction X or induction quote X? I guess we're expecting a symbol anyway, so we can just take the symbol without the quote because we know it's a symbol. So, induction. And we need a second value. That would be a concrete dot symbol X. The good thing about this is that it directly corresponds to a symbol for induction here. An ident. So today I learned that there's a true conflict in parsing Lisp and non-Lisp in the same file, because Lisp has naturally bigger tokens. And I guess the fix for that is to not use tokens, or not tokenization anyway. So intros. Error, unknown tactic. That's for typos. To shift reduce conflict is going to bore me with this. We'll have to find them, hunt them, etc. So what is have? What's the syntax of have currently? Have using. Let's make a slightly simplified thing. We start with have. So I think there's plenty of pattern synonyms to be defined here. To have, I said it's a term, yeah. So we can take a concrete dot tac term of E followed by concrete dot keyword dot list keyword. Oh, sorry, it's both. I think this should be just parsed, so we should have a sort of, you know, data structure representing a form with a certain number of arguments. Right, so we're going to start with these and start exploring. But I need to fix this shift reduce conflict that is left. This keyword colon has colon using and so here we can say list of symbols to sims and can take, oh, these are lems. Yeah, well, right. This isn't readable. But I'm gonna improve on this. It's broken. I guess I'm not. Yeah, okay, this one is too many. This is supposed to be lems and still not happy, I think. Oh yeah, of course. List of symbols takes a concrete list of concrete dot list tag to maybe tag, and we can do that by doing like sorry, maybe a list of concrete but ident. And we do this by doing traverse of a symbol. And a symbol takes one concrete dot list tag. Oh, I know what's happening. One if tab returns one, maybe concrete dot ident. I'm gonna have to fix a ton of typo. A symbol of concrete dot symbol sim equals just sim. a symbol. Maybe I should just have the lens generate prisms for this. Oh, James, you said that 20 minutes ago, but I just realized what you said. Yes, me too. I could only manage to do the file local renames. The global one, at least with retry, they just don't seem to work at all. Okay, so concrete.list tag, because it's Lisp tag. Yes. And that would be replace with concrete.island. Yes. Still not good. Oh, there's a word wrapping that was added for some reason. Okay. List tag can match list tag to indent. Where? Oh yes, that's the P. That's still not good. How is it not in scope? I guess it's just broken because of the other one. Variable non-scope P of type concrete.term. That is very funny. So to the right is GACID. It's just one of GACI. It's very robust, but right now it's saying something very weird. It's saying that the variable I'm using as a pattern is not in scope. That's very, very funny. So what's being wrong? Couldn't match expected type. List tag couldn't match. Can I see that hole? Define P colon term. What does that do when I click this? I'm curious. Did it do anything? Oh yeah, nice. It added a definition of P here. Sorry, here. That's funny. Okay. Concrete.symbol, concrete.tag term. Couldn't match expression of type. Square bracket idents. With what? Lambs is maybe idents. Oh yeah, I need to say just here. I think I should just define myself prisms for this. That would help us on, but well, it's a little. It would just compose quite well, but then right now it's not too hard. So let me restore my VTerm. Maybe. Okay, so I've got these shift reduce conflicts that I have to deal with. Okay, so there's no avoiding it now. I have to figure out what's wrong. What happens when I remove this? I'm going to write something unique here instead. That's a terrible idea, actually. To shift reduce conflicts. It's unrelated to this one. Yeah, let's use a different symbol for this one. To shift reduce. Interesting. And what if I do this again? That is still good. Fascinating. And so I'm guessing it's because of this, the nothing out. Let's go back to prog. What does a prog look like? Where is my prog? A prog is a list of declarations. That's fair. A declaration is a space-separated sequence of declarations. Parse one, and parse the rest. Which I could have written another way. Did it? So we have this list of declaration that I defined a particular way. So fine. Definition is necessarily heralded, so we know we end a definition when we see one of these keywords. So we can't really and by the way, so this shift reduce story, I'm not really sure, but parsers like that, they work as tag machines. So when you encounter a symbol, basically you either push something to the stack or consume some of the stack, I think. If you push something to the stack, it's probably a shift, and then when you consume something from the stack, it's probably a reduce. So there's a point in this grammar, I guess, if my memory or my attempt at remembering thing is not completely faulty, that they don't know if that's a parenthesis, whether they should push the parenthesis or reduce. That means pop something from the stack. And I don't know why. It's only with a parenthesis, so I'm guessing it's that one that poses a problem. This unbalanced thing is probably a bad idea. No, this one is good, but this one breaks all life. Right, even if I do this, right? It's taking hours just to build the bloody syntax. hope all your kids are asleep while I'm swearing. Right, so this token, this here one token, when it's turned into a parenthesis, creates a conflict. A conflict with what exactly? Let me see something. Why is this symbol a problem? What is it conflicting with? So I just called a list tac out. So I'm at the end of a theorem. But I don't know that, really. I guess the problem is that there's simply no herald there. It could just be so square brackets were okay because there's no square brackets in terms, yeah. But there's parentheses in terms. So I'm here. I'm getting to like any expression. So what's happening here? So I'm writing a theorem. Maybe if I can find a theorem. Let me find a theorem. Okay. So one that has a proof. So like I'm writing times a sock, which I guess I could simplify actually. It really wants to show me what's there. So times a sock, which we can't really see. Here it is. I think I can just do have syntax of this. Does this still work? Right, it's even printed the same for some reason. That's miraculous. I guess I'll print the concrete syntax back. That's much more concise. But anyway, the point is I'm here, and here I say, oh, I see a square bracket, so the theorem is done, and I can go and pass a tactic. If I see a parenthesis there, then of course I don't know that the thing is done. I don't have a terminator here, and that is probably a mistake. There's no herald for this. So I was using a very convenient but not very. I'm going to add got another term, proof. Let me do something. So here in the syntax, instead of this, which of course is silly, here when I do a maybe tech out, which is very ill named now, I'm going to say, oh, here is the proof. And I shouldn't have a conflict anymore. So here we are, me and parser are friends again. Okay. We don't print that back, but it's all fine. I've been looking a bit at Tree Sitter recently, which is a tool that has been developed at GitHub, a parser generator of sorts that is meant to generate incremental, fault-tolerant parsers. This is meant to. So the idea is whenever you see a bit of a file, you use your tree setter parser and you pass the sort of chunk of file, and you try to give data back to the editor so that it could color things in a way that is much more rich than a normal regex recognizer that is used usually like in Emacs. The standard way of coloring is say, oh, this is the regex that recognizes thing of this category, and this is the regex that. Yes, there's a couple, I think, but there's one that seems to be way bigger than the others, and I think it's just called Emacs Tree Sitter. The point is, I was looking around. When I first heard of Tree Sitter like a few years ago, there was a Strange Loop talk, 2018 something, 17, I don't remember. And my impression was that the goal of Tree Sitter is to give an inaccurate parsing into sort of broad categories. You don't really want to parse the full syntax. You just want to say, oh, this is a definition sort of thing, and this is an expression sort of thing, and then sort of you do this sort of imprecise parsing. But of recent, it seems that, or maybe not of recent, maybe I just misunderstood from the beginning, but they seem to be advertising making full-blown grammars, like complete, correct grammars for whole languages in Tree Sitter. And what I'm wondering about this is the idea that we just use Tree Sitter as our parser generator for the language and the compiler and so on and so forth? Or do we have two implementations of the grammar? This is something I don't really understand yet. If someone has thoughts, just share them with me, because I'm very, very curious about this thing. I see Tree Sitter as playing a bit of a same role as LSP for syntax coloring. You don't have to put your thing in the idiosyncratic regex language of like 5 or 7 or I don't know how many editors. You just write a Tree Sitter grammar and then you use the Emacs packages and the Vim packages that just do that. Like it's sort of that's the hope. I don't know how accurate it is, and if it's the only reason. It was a sort of a hobby project of someone that works on Atom at GitHub, and so now it's been part of GitHub in various ways. It's used natively by Atom to parse a couple of things, and it's used by the semantics team I think in GitHub. That's also the Haskell programming team in GitHub. They use Tree Sitter to parse some files. If you use certain languages, you will be able to jump to definition, for instance, within GitHub, and that uses Tree Sitter. That's my understanding anyway. Okay, so now we have a working parser. Now let's try to write a couple of proofs, I guess. So this one is great. This one uses intros, have, and done. And these are things we've ported. So let's just try this out. let's duplicate this. Oops. So first we're going to write, yeah, it's not liking this. Proof. Okay, so now we can remove this, but we have to put everything in parentheses. The intros and have, so I need to put this in square brackets. So the British people in chat, do you use the word parenthesis or the word bracket? Oh, well, I guess you might use both, but which would you rather use in a, I don't know, normal conversation? There should be a syntax error. Usually say parent. Okay. It's not happy. Well, I saw a conversation on Twitter on some parentheses versus bracket, and so I wanted to check usage, and I went to the Wiktionary. 116, but that's not going to be the right one. Before intros have. So here there's a, that's interesting. Yeah, so, okay, so we have a, okay, so that's a fixed parser. Yeah, and so it seems that in the US, people tend to use parentheses and bracket, specifically the square bracket, and they would use brace or curly bracket to talk about the curly bracket. But in the UK, it seems that bracket refers to all of them, and bracket without qualifier is usually the parenthesis, and I didn't know that. First, there's a syntax error thing somewhere. I don't know what it is. Oh yeah, I know what it is. I don't know what gives me a, no, I don't know what it's a syntax error actually. But I'm sure. Yes, but I want to point out that this is not very different from the syntax of the previous thing. By using Lisp, we haven't actually lost a ton of syntactic goodies, and we've actually gained a few. And I know what I think I know what the problem is. No, I don't know what the problem is. Oh, I know what the well, okay. There shouldn't be a syntax error, but I've done something wrong. That's not what I want. What I want is this sec. That's a sequence. It's not the greatest of a name, but here's my syntax error, I guess. If I remove this before have times. It's fascinating. But yeah, again, about this usage is never everybody, and I don't know how common some usages are, and there's something wrong. Explain what is wrong. Proof is followed by a parenthesis. Let's start small. Let's start this. Does that give me a syntax error? It doesn't. That is good. How about this? It doesn't give me a syntax error. It doesn't an error, which it should absolutely do. Sick. That works. Shoot. And tactics 6, so that works. And now there's a syntax error. Did I leave some debugging code? Ah, no, I know what the problem is. Oh dear, oh dear, oh dear. Problem is that interest is a keyword. No. Okay. So in order to do that progressively, we're going to have to cheat a bit. So we're going to go back to eval tag thingy, the one before. And we are going to strawberry fields. We're going to cheat. And I guess put a prime in at the end of everything. I'm sad, but I have to. Now I'm going to go back to my thing over here and put a prime at the end of everything. And we're going to remove the prime at the end when we can remove the other syntax. That will clear a ton of things. Don't mock. It's not funny. That is software engineering for you. Adding primes that you don't want because you have to. As I frequently repeat, life is full of trade-offs. So there was the semicolon before. So let's have a look at this. The semicolon is this tactic then. So what we want a case for this. Use a quadruple prime last week, so no judgment. Respect. Quadruple prime. That's sort of the time where you should question your notations. Or maybe like somewhere before 7, I guess. So let's give it some space and consider I'm going to take this one as my basis. So it's still a list. I start with a symbol, and the symbol is sick, and I don't have to put a prime on this one. Hey, then I have tax. Okay. And there I will just like I have to evaluate all the tags, and I get a list of tactics, and then I then them together. Is there a way to do that efficiently? Have a I guess it's fold. Yeah, it's just fold right. So folder. So you start from the left, yes. I could special case for the to avoid the 0 case. Doesn't matter. And so you eval lisp tag. Sorry. How is it called again? Tactic.then. Folder tactic.then. Apply to something. Apply to something. Let's have a look quickly. Okay, we've lost. We've lost spell. Oh, really? Third buffer maybe. It's gonna give me my field color indicator that I can remove again. No, it doesn't help. 1369 ambiguous type variable fun hole of type tac. So this one, I guess I can just look at the type of this. Right, the list is the second one. So this one is tactic.id. That exists, right? Yeah. And so I'm left with this one, which I still can't, and I just want to do a map. That's perfect. Eval lisp tac tax. Boom. Is my, I think I killed plus though. Oops, don't tell me that. I killed it. I did something wrong. Let's have a look. And someone is getting excited about this. That's the one, yeah, that was time plus, ooh. Right. So just to check. Right, I'm gonna take this one. And there was no dispatch, it was just one sequence. It's all very fair. I'm gonna commit this. What can we do? We can restart the workspace. Restart LSP. It's less excited now. Okay, and now we can look at this. So the theorem that we've apparently botched is time plus x. That's the, yeah, I'm just here. Okay. And so let's see where it blocks. Times plus x takes, give me, I have a z and y and x, and times plus x plus time x dead. We just did intros, right? Oops. So let's go slowly. Syntax error. Oh yeah, that's a syntax error. That's definitely a syntax error. So let me remove this out of my way. time plus x. Yeah, so that the intros has made progress, that's for sure. So we can remove everything that is not intros. I'm sorry. What did I do? That was just extremely bizarre. Probably just pressed the button that had an action at a distance. So time plus xyz equals plus time xz time yz. Okay. And I'm supposed to do half prime. And so I'm supposed to add a property to this. There's a few possibilities there. The term is not passed correctly. Or that didn't add anything. Or that times com is not interpreted correctly. It should be. Okay, so what could have happened? We're going to do something. What? I guess this isn't parsed correctly. Just code, mate. I'm very confused sometimes. What is happening? That doesn't look good. Maybe I can skip the error there. That's quite curious. Seems to be catching the error too. But it didn't earlier, right? If I do this, it gives me an error, right? Like right, that gives me an error. Masked by the folder, it shouldn't be. Did it not run? Did I do something weird? I guess the problem is the semantic of sec. I don't have a fail tactic, I think. But the point is that even if maybe even the first one, can I do the first one and make an error? Okay, so the first one fails. Does intros. Never. Why? It's just so weird. Okay. The first intros is run, but the second tactic is never ran. So if I write random things, it doesn't work. Doesn't do anything. So that's my problem. Let's go back to the definition of sec. Another thing that doesn't work yet, at least not with my version, is jumping to definition in another package. If I do Y here, it says no definition found. Val tag tag 1, TCL then, val tag tag 2. I am, to be honest, quite a bit confused about what could be going wrong here. And something is evidently going wrong. Trace. Show. Right, so that looks pretty decent. Never does the second one. Why? Why does it not do the second one? I am very puzzled right now. I don't even know where to start. Yeah, the wrote 7 here. If you just I'm grasping for straws. Didn't even call eval a second time. Why? Why would that be? Yeah, but it works here. At least it calls it once. So calls fold R and just stops and never goes. I don't get it. Let's go to the definition of then anyway. Sorry, let's go here on the definition of then. Yes, that's what's happening. It's lazy, but it never evaluates the second term, which it absolutely should. Let's see. Tactic. That is true. Then is not associative. And we're associating it the wrong way, I think. That doesn't quite explain what we're seeing, but the problem is right. So the problem is that we want as it stands. So let's have a look at the grammar for a second. Well, one of the problem anyway. I'm not sure it's the problem. That would be a bit presumptuous. Oh, yes, but so yes, it's what am I saying? No, I think you're right. It's associative, sort of, kind of. There are some weird things happening. How can I make a weird thing happening? I'm not sure. I'm not sure I can. Maybe it was just. Maybe then is actually associative, and just dispatch makes things non-associative. I don't remember. There's something fishy about then, because it's the composition of two traversals ish. I guess sort of that has to make it associative. Interesting. At any rate, we're associating it to the right, so we're doing exactly the same thing as before. No, it's the opposite as before. Before we do the first tactic and then we do the second tactic immediately, and then we apply the thing to the result of this, etc., etc. And here, because we're doing a fold R, we're building the expression that applies all the tactics. We apply that to the. But what? It doesn't make any sense anyway. It doesn't explain what we're seeing. What is happening? What is happening? Why don't I actually? I'm getting confused. Confused is not good. Well, fold L is the wrong way around. Could do a fold L of reverse, but that's somewhat. I'm not sure it fixes the problem. Or fold L of flip maybe would work. What does fold L do? Of course, it doesn't have a good definition. Or maybe I'm wrong. Maybe folder is what I want. Maybe I'm just confused today. Maybe I shouldn't be trusted with a computer or keyboard today. Maybe that's the answer. If it fixes the problem, I'm gonna be mad because I have no idea what's happening. Though it's probably better anyway. It doesn't though. Yes. I'm saying nonsense tonight. You're right. This is more than a little puzzling. Let's try no, let's just see what we can do if we do T take the done. Val lisp tac T you got stuck at the same step after one tactic. Let me try some more things. Not going to change anything. I hope, because I don't think I wrote ID, and I would have seen it because there would have been a mistake. So if I go back to interest prime here, and I add an ID prime in front, will I have 0 tactics done? No intros is not meant to be discharge. Did I write intros equals discharge? Was I really backing up the wrong tree all that time because of something stupid like this? Oh, yes, I was. Oh, yes, I was. Thank you very much. Of course it would be this. I am so very, very sad. Well, thank you. I could have spent like half an hour more on this. Remove import. I don't really need to click buttons for this. Dear Lord. as a result of that, it's midnight and we have barely started on this task quest thing of making more things. Yes, it's just as easy to add focus. But let's convert a few more things and see lazily if we need more tactics. And maybe at some point we'll do a better job at parsing them. I don't. For instance, this needs dispatch. So I'm going to add dispatch. Now that's very interesting, actually, because I kind of want to keep the sequence and look at this as if it were a part of the sequence, I think. Because it won't... Adding dispatch is interesting. How do I want to do this, actually? Right, and we frequently do something like this, right? I don't have an example right here. There must be some, like some quick dispatch, and I go away, like something like this. I do a quick dispatch and I continue. So either, yeah, dispatch is a fairly reasonable thing as part of the sequence. So the cheaty thing here in the normal syntax is that this semicolon here and this semicolon here, they are completely different. This one is the then, and this one paired with this square bracket is what's happening. is the dispatch thing. It's something that, you know, still exists in Cog, but in Cog there's this syntax that I have introduced because I was very uninspired. And then this is the normal then, and this becomes a multi-goal tactic that does the dispatch. But because I don't have multi-goal tactics in the system that we're building right now, I want to do something. That being said, I still want this to look like, you know, something like sick with n, chain, and dispatch done id, something like that, yeah? So we're going to teach seek to deal with two kinds of things that are either tactic or dispatch. So I think that's the first thing to do. Should be good, right? I think there's nothing changed here. We can kill this bit and commit this as a fix. Yeah. So we need another function that is mutually recursive. Eval dispatchable. It takes a concrete list attack and return to dispatchable. So we need something for this, otherwise it's going to keep complaining, and I need the type dispatchable as well. Data dispatchable is either a dispatch of I guess the list of tag or a tag, a single. Of tag. Single is not really the best name, but whatever. And so this takes if it's list, it starts with a concrete dot symbol. The symbol is a concrete dot ident, and it's dispatch. And we then have a list of tags. Interesting. What is Control C, Control S? Okay. I didn't know that. What happens if I do it here? Fair enough. And tags, then I return dispatch of map eval list tag. No. Shh. Okay. Dollar map eval lisp tags. Yes, it's a tactic that fails if there is at least one goal. So it's the way you typically it's one way to implement the solved tactic, a tactic that checks that you've done you finish your thing. It's particularly useful if you have a backtracking semantics, but not only. Like if you have a disjunction of possible tactics they can apply, and you want them to solve the thing, you can just say, oh, you can add the solve thing, so dispatch MT at the end. Okay, I found the bug before I could read the problem. And so in any other case, eval dispatchable of T will be eval lisp tag. Yes, absolutely. So that's why single is terribly named. So it should be called all. It means that you apply the same tag to every single of the goals. So this one has a fixed number of goals, and it needs to apply to different ones. So there could be a way to there's a way to unify the two, and that doesn't have the right type. For some reason, it doesn't complain. Why doesn't it complain? That is really wrong. Ambiguous all. Yes, it's a sort of a strict zip. Right. It's a very useful thing. It's what lets you just. It's basically it's how you apply different tactics to different goals. Right now, since we're taking if we start with a single goal, that we just write one tactic and not different tactics. This dispatch thing is completely central to our thing. So now we need then dispatch function that takes. Now we won't have a choice whether full del or full del, or just one of them will work. So it takes attack and dispatchable and returns attack. And then dispatch. I think it's rather than dispatchable, but let's call it then disp because it's local and it's starting to be a bit annoying. Of t and dispatch t's. I usually say tag, so let's say tag. Tags equals tactic.dispatch tags defined but not used, which is a good point. And here we have on all. So in old-time eCog, oops. That's exactly what happened. There was one tactic that was called TCL, then 3 parts, and it was a list, a tactic, and another list. And if both lists were empty, then it would be would define then, and dispatch is like the first list is not empty, and the one middle tactic is fail and things like this. It's not used yet, but instead of using list tag here, we're going to do eval dispatchable, and now TCL then doesn't work, but it says that doesn't work, but it's fine. And here we just map then disp, which I think full del will be better, actually. It is. Now we can do dispatch. Wowza. So let's go back to our things and do the first theorem. I'm going to copy this. We're going to write proof, not proof env. I don't know why I wanted this to be written. I'm going to write this and remove this. We can no, this, yes, we can remove this. So that's a dispatch. Interesting. Here we have a sick. I don't have induction yet. Ooh, I'll have to fix this. So here again, we can have a sec. So I had an extra line for good reason. Okay, that was me trying to write sec. Okay. Again, we can remove this. We can remove this. We can actually remove. No, here we have a sec to write. Fantastic. I'm good. Just double checking quickly with this. Intros, then by induction, then a dispatch that spans the entire thing. I can do this. Okay, and this. Having many parentheses like that is a bit less, it takes a bit less space, but it's also a bit aggressive for your diffs. They tend to interact with every changes. That's what we're doing here. We're saying, oh, we do intro, then we do induction, then we have two goals. So this is the thing, the goal, the base case and the induction case, and so we say, oh, we're going to do a different tactic on each of them, and so that would be the tactic there. So I think we're good about this. Not completely done, so maybe I shouldn't remove that yet. So this is, oops. This, ooh, I don't know how I did this, but that was cool. Colon, and this, nope. Colon. Okay. Yes, I just assume that it's a form. I'm not sure that I need that, but since it's going to be difficult to do the other things without parentheses, for now, I'm just doing that by symmetry. It feels more lispy, and that's pretty much it. Looks pretty good. And now I want to do just induction, I guess. Oh yeah, primes. I just have to define induction prime, because right now I'm going to have a non-existent form. Too many tactics, 3 too many. Okay, that wasn't expected. So this is a bug from dispatch. If we go to tactic, dispatch. No, isn't that from dispatch? Too many. This is a type from apply tags. So he sees 4 tactics instead of 1 here. That should really be just the 1. Let's just take the opportunity to add a space here. So what am I doing? Got a bunch of tactics. Yes. Sorry. Right. And these are tackouts. So here, apply tack. So I get in the last case. I do map of our list tags. I am not. It looked very much like I am. Plus, it's really the outer one that we're seeing here. That's the sick. That we're seeing several of. So this is closed here. Sorry. So let's make sure debug.trace doesn't offer me to add the thing. Trace show length tags. Should just give me a way to print the tag text right now. That one. I could do this. It gets 4 tactics. That's not good. I don't know why yet. I don't know why yet. I think I just forgot one parenthesis or something. Right, I think that's just it. We go there. There's one extra parenthesis around it. Yeah, that's just it. So we start with 2 parentheses. Oops. And that's it. Yeah. That's because it's there could be several goals, so it needs to know that it's just a single goal that is a sec. That's all. That's the sort of thing that we could improve later. Like having a single sec being the same thing as oh, we can leverage. We can like parse the semantics. It's fine, I guess. Debug trace. It is easier to do this sort of mistakes than with the other syntax, that's for sure. But then again, I like to insist on the fact that this is not very different. It looks a bit like the previous one, and the syntax is going to be way easier to manipulate. So I think it's not much of a loss. A bit of one, I guess. We need use for this one. Oh, we need induction now, I guess. Maybe I already did induction. Yes, I did. That one. Ah, I did induction. Yes. So we have an extra one. I need use for the next one. So what is the syntax for use? Am I going to have macros? In another life, maybe. I'm not sure I'm looking forward to implementing macros for real. It looks like it's a terrible thing to do. Once it's done, your life is much better. But getting there looks like it's quite the pain. I mean, like, not macros, but having a decent system of macros, like the, like, whatever Racket is doing. Like, even just hygienic macros is non-funny thing. Okay, use. We can use this. We can make this simple use. That doesn't have an argument yet, and then we'll try not to make a copy paste mistake this time. That's a good point. Not yet, no. So I guess we can make macros before we have these. Hey David, good morning indeed. How are you doing? And so my point was to do why is it tack? I seem wide awake. Maybe I am. I'm gonna call this X. So use colon concrete dot symbol X. Okay. Well, that's good. I'm awake. It means that I'm in a pretty good shape. Ooh. So this parser is not this little parser is not particularly fun, but the good thing is that we can progressively abstract on this. We could add slant. Slunch. I don't know what you're talking about. Ah, I get it. Yes. So use exists now. It takes a symbol as an argument, which I hope is going to be enough. For on next tactic thing. It's just panicking a little. I don't know what happened. Not that meme. The audio and video are clearly not sync over here. That's unfortunate. Yeah, that was correct, definitely. I think I've already witnessed this behavior, but I think there are some recordings where the audio and video are not synced. But this is not what should happen. What should happen is if the video is late, then some frames should be dropped to catch up with the audio. Like, I guess it's not too serious, but kind of there. How long is the delay? Maybe my sound. You know, I've got a pipeline that deals with sound and does some effects. Well, not effects, but some cleanup on the sound, and maybe that's what's slow. I don't know. About 3 seconds, so that's definitely not my signal processing thing. And sound is faster than light. Yeah, that makes sense, I guess. Interesting. I don't know how to deal with this. Like, I don't know if it's my fault. I mean, if it's something in my computer, if it's Twitch that does that for you, like, and if it's on my computer, I don't know what I can do to fix it. Me clap once. That was not a very loud clap. Oh, you need to see the hands. Okay. Oh yeah, I get the point. Also, I didn't look at my camera earlier, so 3 seconds, I see. About 1 second. If you don't have the same delay, it sounds like it's not on my end. So it might be Twitch that's being very, very slow. Both using Linux and watching Twitch on the website, I assume. Because that could be it. Switching the video. I'm starting to be very slow at this. Intros induction, use plus x, done, half plus 0, done. Incorrect number of goals. Again, not something I expected. Oh, there's a device function for selling stuff. Sure. On the other hand, I'm not sure it passes my ad hoc tactics thing. Incorrect number of goals, not what I expected at all. It's not working. Gonna write use prime. I'm gonna change anything. So let's have a look. So we take all the dispatch. Remove it. And see what we get to see. Looks like it looks very much like 2 goals. Very, very much like so. So what's wrong? And that also looked. Ooh. Oops. Thanks, Lisp. So yeah, Lisp is not without costs. Yes. Okay, so that worked. So is there a list that uses features we haven't introduced yet? There are, though. Like this one. Okay. So this one uses focus, which has more or less the same syntaxes have. And it uses with, and it uses chain. And deactivate. What is serious, sorry? Okay. Focus with chain deactivate. Do remember that Lisp is the second ever programming language. It's very traditional. Programming language. The first one was Fortran, by the way, in 57, and Lisp is 59, if I remember correctly. And Ada is much, much more recent than this. It's like in the 70s or even the 80s. No, it goes basically, you know, Fortran, Lisp, Algol, bad things, and then do I need to answer this question? Honestly. Yes, I can just. It's a nice question though. Really? So Ada is the consequence of NASA trying to design a language that would have reasonable robustness property so that they can do stuff. So it is probably one of the most carefully designed language, but it's fairly recent, and it's named after Ada Lovelace, quite definitely. But it's completely unrelated to her work, which so her mathematical work that is currently well known is her writing program for the analytical machine of Babbage. Yeah, well, computer. So she wrote programs on a notebook, yeah, because the analytical machine was never fully realized. At the very least, she never touched one. So it's a bit arguable whether it was the first program ever written, because there has been other computers before, just not quite like this one. So this was a very generic computer that's I think was fairly digital. I don't remember. Well, I don't know what kind of notebooks they had in the 80s, but notebook probably existed as a word. Yeah, I think they realized an analytical machine recently, yeah? The full-blown, the complete machine that Babbage never completed. Babbage made some intermediate thing that were not quite the same thing. I think. I don't remember exactly. That's quite a fascinating story, actually, but yeah. And so yeah, Lovelace, she just, I don't know that she even met Babbage. She just took his description and wrote programs, among other things. I don't exactly know what she did. She did quite a bit of maths in general. And oh yeah, it's a completely mechanical thing, much like the Pascaline, which is one of the first mechanical computer. But the Pascaline is very reduced in the set of instruction. It just does arithmetic, basically. But as far as I'm aware, it's quite a bit older than Babbage's computer. So it's just there's a sort of a continuum. But the first thing that was ever deserving of the name programming language, that had a rich enough structure, algebraic structure in it, to be called such, was Fortran in 1957. Interesting. You can read about the Ada language. It's actually fairly decent, and it's and they write rockets with it, and sometimes they blow up rockets with it. So, oops. Blowing up a rocket is fairly traumatic, because when you send a rocket up, there's always the rocket is extremely expensive, but whatever in it is just so massively expensive. The first Ariane 5 flight exploded. Well, was exploded really, because it went haywire, and it was due to some code module written in Ada. Well, I mean, NASA designed Ada, but they're not the only users. Designed or made a competition for the design of this. I don't remember exactly. I'm losing track of what I'm doing. I need with and I need deactivate, yeah? I'm just taking this with me. with and term. Do I have one of these? I don't, so let's just take this. It's fine. I mean, you know, with prime, concrete symbol, I don't want concrete symbol here, I want tag term. Tag term. I don't want induction, anywho. Bring up. Okay, and I need deactivate, and deactivate is just a plain call to deactivate, right? Right. So let's just take intro, or no. Okay, I have none that works directly. Deactivate and deactivate. I mean, the history of programming language is quite fascinating. There's been I mean, it's been a long journey to get where we're at now, and it's been very, very interesting. And there's been a lot of different trade-offs that have been made, and some like stood the test of time, and some didn't. But also, we have to remember that we're still in the early history of programming languages. So we're living history, and like, whatever programming languages look like in 100 years will be quite as foreign to us as Haskell would have looked in the 50s, most likely. And that's a very, very exciting perspective. Div 1. It's a proof theorem, yeah? Where is div 1? Here it is. Yes, proved. Yes. Okay. What do I want it? I think I want it here. I don't know exactly. Let's go. That's not gonna work. Can I do this here? Oh, that works. Boom. And that was high-powered Haskell right there. Emacs right there. Editing. So dispatch. We can add a sec rather. Now we have to add the primes. And in that particular case, I have to use this. I'm pretty sure there's some way in my Emacs to replace the enclosing parentheses, but I don't know how to do this. So I always create some and destruct some. Done prime, it prime. Oops. This is quite true. A known tactic with prime. Interesting. A known tactic with prime. Because it's not followed by a term, is it? Right, it should be. So here is an example of something that would be improved if I had better patterns. A known tactic chain prime. I think I just didn't code chain. Oops. Right, like right now I'm writing my patterns in a very ad hoc way, but I could have sort of views that give me a better pattern matching on the thing that would give me better errors. Like in a way, Racket's patterns are kind of perfect. Say, oh, I'm discovering something that should match a macro, but it's not quite the right syntax. And I guess that's kind of what we want. Yeah, I don't know why I did this, but it's fine. Instead of saying, "Oh, I don't know what's happening. I got in the wrong thing," it's just, "Oh, you used with, but I was expecting a term after it and not a symbol, and you gave me a symbol, and I don't like it." Something like this. That would be a way better error message. And one way to achieve this is to say, "Oh, let's just do the same sort of macros that Racket does. We can do them in Haskell, or we could have a sort of low-level primitive things or a tactical thing, and just and desugar. There would be a way to do that, like by lowering some syntax to a more primitive syntax within Lisp itself, which I guess would be an exercise, but I'm not sure I want to go there right now. What I'm probably going to try doing very, very soon. Maybe not today. It's 1 in the morning already, so not much more interesting things that we can do. We can convert times a sock maybe, which is one of the last. It's not really one of the last. It's low in them. So it's to give yourself like maybe it's a good opportunity to learn about racket syntax rules and try to reproduce a similar logic in Haskell. Give us combinators to do the same sort of things, and let failures be informative. So I think that's what happens in Racket by default with the normal macro expander. Racket looks at the first symbol of the form and says, okay, this is a form I know. And after that, it says, okay, so this form has this particular shape. And if something is not of that shape, I give a message saying, oh, I expected something of that shape and I saw something of a different shape or something. My experience with Racket is essentially 0. So it's mostly by reading a bit of documentation that I came to this understanding. I may be very wrong. James, you did do some Racket, right? Yes, that's the point. But it's just because these are like regular Haskell patterns and they're not patterns that are adapted to matching on Lisp and do this sort of things. There should be a sort of mechanical way to do exactly what I just said. Like look at the form and then apply some pattern matching on the rest. Okay, have a good night. I'm going to stop very soon. Just for the record, this is my last programming stream of 2020. So probably we see each other in January. For holiday stuff is coming and I'll be busy on Fridays soon. I'm busy doing other things, unfortunately. So there. So anyway, have a good night. So next week I'm going to do a video game, and then for 4 weeks I'll be away from the computer, basically, at least away from my streams. So there will be a 5-week gap between the next stream and the one after that. Well, I mean, I'll be working some of this, so I'll be on the computer some of it. No, that's probably not possible for me. But joke aside, I won't be streaming, so I'll adopt a different rhythm of life for a while, mostly because, family stuff. I say mostly, but that means exactly because of family stuff. That's just a coincidence, really. I didn't plan to play during my holidays, to stream during my holidays. But it so happens then that the weeks before I'm actually busy. I did something wrong. Thank you. good. Where's that supposed to be? There's one missing. Okay, that's not expected. I think this one is missing. Yeah. Fantastic. Okay, so now I need to also add can I do this? I know how to do this. Oops. It's just, would have been faster not to try to do this. It's just sort of a challenge. Boom. I just realized how I could have inputted the colon in one go. So, where are we? Syntax error before intros. Induction. It's very surprising. Okay, so there's no error. Does that type? So, fantastic. So I think I'm going to stop here. There's not much more to do that we haven't done yet. That gives me some interesting research to do, even though my plan is kind of not to do too much in December. So we may get into a weird step in January. Well, I think I'm gonna stop here, mostly for this stream. We've learned a few things about Lisp, and I think we're going to learn some more. Yes, I hope that we can finish that fairly quickly. I may do some offline. I don't exactly know, depending on how things go. So where was I? Yes, so my goal next is to improve the parsing of the Lisp a little, giving me more ability to read all the arguments. Right now I don't need to really with all the tactics that I have, giving me generic optional arguments to use as an optional argument that is in the grammar. I haven't seen the use using the optional argument, but if it had, if I couldn't find one example in my tactics, which I may, then we can see that. And so yeah, pretty generally having a generic way to express these features, to express the patterns of each form, so that we can have both a sort of easy way to declare tactics, saying, oh, I've got a form and it has this thing, and then you give me the result, and sort of generic error messages that will, and then we can remove the custom syntax. I do find that this syntax is really not worse than the other one. Just looking at two fairly similar proof here, sort of, it's a bit less good. Like this sort of lines takes a bit more reading than this, say. So this here is the same as this. So this is sort of where the normal syntax is a bit better. However, well, this is going to be good is that we can take all of this into a different file and we can make a very quick syntax highlighter that will be stable and will just recognize tactic forms or something, and just be able to highlight the shape of these things in a fairly decent way, and we're going to be able to read a bit. We'll have to make sure we recognize these and pass these as terms, which is a bit hard. The problem is that our syntax is a bit context dependent, which is not something that Emacs deals with very well, which might push me towards using Tweetsitter for that, because Tweetsitter is context sensitive, so we can do that pretty easily. At least more context sensitive, and we can, like, because these terms are pretty unreadable because they're yellow right here. So we move them in the file and be able to pass the file. That would be quite decent. So we're going to do much of these. So it seems that these distractions that I have at the bottom of the file are still going to keep us busy while I get better ideas of how I want to move forward. It's less mathematically interesting than the rest of the design, but it's also a part of Professors in Design. You have to deal with all these things that might be boring a bit, but we're trying to do that in a way that we are sort of satisfied with the software engineering part of it. So I've got a bunch of ideas coming on of very like low level things like this, like not really logical design or logic level design, but rather like sort of facilities. And so among the distractions, there was this idea that we could use an LSP server and maybe sort of have instead of printing the goals the way I do, just go there and have the LSP server tell me, oh, the goal at this point was this, for instance. I'm not exactly sure how I want to do this, but having that on the hover might make sense. It's so it's kind of open, and I think that's sort of what we're going to explore this winter. More infrastructure, and then we're going to come back to the logic and make progress. I'm sure there's so much interesting things to do. So many interesting, so much that is interesting to do. Yes, did I commit? Right, I didn't. More whip. We're gonna make a branch. Lispification. I think for me, this is okay. That's not what I wanted to do, but fair enough. I think for me, this is a good opportunity to delve a bit deeper into this wonderful word of Racket macros, how they're defined, and the entire the logic behind this, and whether we can sort of reproduce similar patterns. I've got this idea. So because everything is as expressions, and as expressions is fairly simple, we can give ourselves a few prisms and traversals and so on and so forth. And with these, we can compose fairly powerful patterns. So I think that will be the first thing that I'll do. I'll just give myself a bunch of of basic prisms, of lens-like things, and I'm going to be using them to define my my logic. So I think there's a lot of the composition. You kind of want to say, oh, this is the list, so this is the head. So I know the head, this is a form, so I get the tail of the list, and I will transform the list into lists and maybe segment it according to keywords. And then after that, maybe I'll want to to push some types within something like this. And maybe I'm not entirely sure that it's going to work, but I've got this idea that maybe lenses will give me a good language for this. So we're gonna play with this in the near future. Maybe I'll do some of that offline, and we'll get there, and I'll explain it. I'll just show it, and we'll program with it. So I've been babbling for 10 minutes with no rhyme or reason. I'll just go over the schedule again. So next week, some video game. I don't have a plan yet. Double check that I've pushed. Yeah. Sorry. The season. So next week, some video games, no plan, but something, and that will be the end of 2020 on stream for me, and we'll see one another again. I don't know if it will be for programming or video game on the 8th of January. I'll check on Twitch whether I can put that in my profile if it helps. Yes, I think that's all for me. So good night or good morning if you're in that part of the world. Again, thanks everyone who's watching, and good evening and good whatever. So yeah, thanks everyone for watching, and so see you next time, I hope. And until then, don't forget to stay curious.